Algebus Packaging Corporation.
Hi, welcome to Algebus.
Hey there, you whippersnappers! I have this new packaging for my innovative product, Cheeseless Cheese, and I wanted to see how much cheese I could fit in it. I thought I'd get one of you lazy young'uns to do it for me.
Here at Algebuds, we strive to help you package your product efficiently.
So what do you even do anyway?
Well, we can help you calculate the volume of this cylinder so you know how much wax to put in.
We can also help you calculate the volume of this triangular prism so you can find out how much chocolate you can put in it.
We can also help you find the volume of this bag so you know how much air and how much chips to put in.
Grandpa, I think they're good. Let's do business with them.
More cheese, more profit. Good for me.
Grandpa Patel and Avni had a neck of a rectangular pyramid of 12 by 6 and wanted to calculate the volume of cheeseless cheese that would fit in it. To solve this problem, we need to understand a couple of terms. First, a net of the shape. The net of a 3D shape is what it looks like when it's opened out flat. A net can be folded up to make that 3D shape, so it is very important in packaging. For example, a net of a cube looks like this. And a net of pyramid looks like this.
Next, congruent triangles. Congruent means equal. Two triangles are said to be congruent if all the sides and angles of a triangle are equal to the corresponding sides and angles of its congruent triangle. Orientation doesn't matter for congruency. Isosceles triangle. The rule for an isosceles triangle is that the triangle must have two sides of equal length. These two sides are called the legs of a triangle, and the unequal side is called the base.
Now that we know what congruency and isosceles triangles are, let's apply this in our problem. In this figure, it's an isosceles triangle. It has two legs of length 7 inches. There are two sets of congruent triangles. The blue triangles are congruent with each other, and the green triangles are congruent with each other. We're looking to find the height of these triangles. Now that we know that there are isosceles triangles, we can draw a perpendicular here, and it'll be the midpoint of the base. So the base of this triangle is half of 6, which is 3. This side is 7. We can now calculate the height of the perpendicular by using our handy-dandy Pythagorean theorem. Plugging values in, you can get the height as root 40. While you're at it, let's do the same for the other triangle. It's always a good idea to solve the problem multiple ways so that you know your answer is correct. In this triangle, the base is half of 12, which is 6, and the hypotenuse is 7. Again, using the Pythagorean theorem, you can get the root of 13.
Hi, so now that we know the lengths of these two segments, we'll be able to find the height of the pyramid and its volume. First, we need to find the midpoint's dimensions. Because it's the midpoint, we know its dimensions will be half of the base's dimensions, and so we know it'll be 3 inches by 6 inches. There's two ways of finding the height of this pyramid. The first way is using the Pythagorean theorem and the root of 40 measurement. We can insert the root of 40 measurement into the Pythagorean theorem equation. In the equation, x represents the height of the pyramid, and 6 represents the bigger dimension of the midpoint. We can insert the values into the equation and we get 2 is equal to x, and so we know the height of the pyramid has to equal to 2 inches. The second way we can find the height of this pyramid is using the Pythagorean theorem again, but this time using the root of 13 measurement. We can insert the root of 13 measurement into the equation. In the equation, x represents the height of the pyramid again, but the 3 represents the shorter dimension of the midpoint. After we insert the values into the Pythagorean theorem equation, we get 2 is equal to x, and so we know the height of the pyramid has to equal to 2 inches. Now that we have the height of the pyramid, we can find the volume by using the formula length times width times height times 1/3. After we insert the values into the equation, we get the volume is equal to 48 inches cubed. Thank you.
Grandpa Patel followed the advice from Algebuds Packaging and filled all 48-inch cube with cheeseless cheese. The product was a huge hit with a minimalist audience, and soon they were loving it.
We've done it! Your pyramid packaging is a success.